A vehicle is equipped with different aerial systems used for different purposes. For radio reception, either a rod type or window aerial is necessary. For exact navigation, the navigation device requires GPS satellite signals. Normally, these are received via the roof aerial. Reception quality when making phone calls is also improved by a separate aerial. The onboard supply control unit is the receiver for the central locking remote control. The aerial is either integrated into the wiring harness or part of the control unit. The remote control signals for the auxiliary heater are received by the roof aerial and transmitted to the radio receiver. As soon as the command has been accepted, positive feedback is passed to the remote control. Most state-of-the-art vehicles use multiple aerial systems. They allow for wireless communication between the vehicle and the outside world. Every type of communication requires at least one transmitter and one receiver. The transmitter needs an aerial to radiate signals in the form of electromagnetic waves. An aerial is an electric conductor actuated by a transmitter. It radiates the received signals. These signals are picked up by the receiver's aerial. The most commonly used receiver in vehicles is the radio. The radio receives signals transmitted from a radio station. This is a unilateral type of communication. The radio device exclusively operates as receiver. The vehicle's telephony system, however, is based on two-way communication. The mobile phone both receives and transmits electromagnetic waves. The waves to be received are always generated by the transmitter. The principle is similar to that of a light signal device. As the light is switched on and off, the transmitter opens and closes the electric circuit. These resulting oscillations spread in a wave. Other than in water, electromagnetic waves are invisible. The waves always transmit energy. A wave consists of a trough and a crest. The two together form a wavelength. Each electromagnetic wave has its own frequency and therefore a particular number of oscillations per second. The more oscillations occurring in 1 second, the higher the frequency. The unit for frequency is the hertz. Another important wave feature is its height or intensity. The range of each transmitter is limited. Among other factors, it depends on the transmitting power. For example, a remote control for an auxiliary heater has a range of more than 100 meters on open terrain. Possible interfering factors include buildings and trees, radio towers and transmitting devices, trams or power lines. These interferences reduce the range of the auxiliary heater's remote control. In addition to transmit messages close to the ground, the vehicle aerial can also receive satellite signals. Among other things, satellite signals are used to calculate the vehicle position for navigation. The signals pass through the Earth's ionosphere and are received by the vehicle aerial. As a receiver, the vehicle continuously changes its position with regard to the transmitter. The received signal is thus subject to variations in strength. The aerial amplifier compensates for these fluctuations. The amplifier is located between the aerial and the radio. It is also called the impedance transformer. The impedance transformer converts the aerial's alternating current resistance to that of the cable. It amplifies the wave intensity without changing its length or corresponding frequency. It then sends the amplified signals via a coaxial cable to the radio. Coaxial cables are bipolar with a concentric structure. They consist of an inner and an outer conductor with a dielectric insulator in between. Coaxial cables are especially suitable for vehicle aerial systems because they are able to supply the amplifier with voltage and carry out signal transmission at the same time. The coaxial cable is connected to the radio via a special plug, the FACRA connector. These types of plugs were developed especially for automotive electronics. The benefits of the FACRA connector are strong contact, a tight lock and, as a result, good signal transmission. Using the aerial and amplifier, the radio can receive the different frequencies transmitted by the radio stations. Vehicles without a rod type or roof aerial are often equipped with a wire aerial in the rear or side window. The entire heating area of the rear window heating serves as an aerial. The wires therefore have two functions: heating and receiving radio signals. To filter out high-frequency signals, trap circuits must be installed. These are 2 FM trap circuits and 1 AM trap circuit. The aerial amplifier or impedance transformer of the Passat, for example, is located within the upper window area. The signals received by the aerial are sent via the aerial amplifier to the radio. A side window aerial can be installed when the window is large enough and stationary. In most cases, it is attached in parallel to the electric field lines to achieve maximum field intensity. Using a radio transmitter, the vehicle can be locked and unlocked without using a key. This is integrated into the remote control. When the locking button is pushed, the key sends a signal to the onboard supply control unit. The receiving aerial for the onboard supply control device can be designed as a cable antenna by means of a discrete wire. It may also be a part of the onboard supply control unit. Normally, the vehicle body is made of metal. Thanks to the Faraday cage principle, a driver is usually well protected against lightning strikes. A lightning flash does not have a defined wavelength. The majority of its energy is transferred within a long wave range. Thus, it is not able to penetrate the glass pane of the vehicle. The radio signals to be received are located within the microwave range. They have a very short wavelength. This reduces shielding through body parts, facilitating signal reception. Everyday appliances such as televisions often make use of satellite signals. These signals are also processed in vehicles. Navigation systems make use of GPS, the Global Positioning System. Around 24 GPS satellites simultaneously transmit signals to indicate their position. In the Gulf, for example, the GPS aerial is integrated into the roof aerial. It transmits the satellite data to the vehicle's navigation system. To be able to calculate the vehicle's position, it requires the signals of at least 3 satellites. For wireless communication between the vehicle and the outside world, different aerial systems are used. These differ in functionality and design.